Now that we have reviewed the 5 different types of forces that we can observe in the macroscopic situation, let's move on to see how we can illustrate the forces acting on an object using a free body diagram. Okay, so why do we draw a free body diagram in the first place? Why do we draw a free body diagram? Sorry, writing. Okay, so you know that there are 5 different types of forces that we can observe in a macroscopic situation, but in different kind of situations, you have different combination of forces that are acting on object. Sometimes it's only gravity, which is the case where we have studied in chapter 2 for projectile motion. The only forces that is exerting on the object is the gravity. But in certain kind of situation, you have a combination of forces that is acting on an object. Let's say if you place a block on the table, then because the block is in contact with the table, then you experience a normal force. But at the same time, because the block has mass and is near Earth, you also experience gravity as well. So there are a combination of forces, and in certain situations, the forces can be all acting in different directions. Let's say for the situation for the block putting on the table, what if I attach it to a rope and pull it to the right? Then now you have an even more complicated combination of forces acting on an object, and they are all in different directions and they may have different magnitudes as well. So it's important for us to be able to illustrate all these forces that are acting on an object. So that is where the free body diagram comes in, because free body diagram allows us to illustrate all the forces that are being exerted on an object. The keyword is on an object. It is not exerted by an object, it is exerted on an object. So it means we are only drawing the forces that an object experiences. We are only drawing the forces that an object feels due to other object pushing it or pulling it, or things like that. Okay, experience, the object experience what kind of forces, only you draw those forces in the free body diagram. Okay, so after that, after we draw the free body diagram, we'll move on to the section where we talk about the 3 Newton's law of motion, and at there we will do our summation of vector to determine the resultant net force. We determine the resultant force or the net force, and we relate the resultant force or the net force, we relate it to acceleration, which is the kinematics part. So F equals ma here is a very important equation actually, because it is relating the resultant force and the acceleration. When you relate between net force and acceleration, you are relating between 2 different fields of mechanics. Okay, let's keep it short. Forces here are the cause of motion. They are the cause of motion, and because of net force, therefore that object changes its state of motion. Therefore, the object behaves the way it behaves. Okay, so the cause is the net force, the effect is the motion that you observe. Due to you having certain net force, or due to you having zero net force, therefore the object moves the way it moves. So this equation is very important because it relates between the cause and effect, which is the cause, the dynamics part of the physics, and the effect, the kinematics part of the physics. So it's relating cause and effect, dynamics and kinematics. So therefore, I think this is one of the very important equation for our study of motion. Okay, so let's try to draw free body diagram. To draw a free body diagram, I usually follow a systematic step to draw a free body diagram. So first thing is I determine what is my object of interest. You might think this is silly. Isn't it very straightforward? What am I drawing? I should be drawing for the block. But situations can get complicated. At certain moments, you might not be drawing the free body diagram of the block. You might be drawing free body diagram of a certain point which don't even has mass. Or at certain moment, you might be, things can be complicated, and at certain times, what is your object of interest can be confusing as well. Therefore, the first step should always be to determine the object of interest. Because after we determine the object of interest, only we know what kind of forces are acting on an object of interest, then only we are able to label it. You need to determine the object, only you can determine the forces acting on the object. Only you are able to label the forces in the free body diagram. Things should go step by step. Next, you think about how the axis should be oriented. When I say axis, it's the x and y axis that you usually heard of. Okay, but x and y axis, if you review back in chapter 1, I mentioned that x and y axis can sometimes be oriented not in the vertical and horizontal and vertical way that we usually think. Occasionally, it can be slanted to accommodate to the situation that we have. So a good tip that you can keep in mind is that one of the axes should be aligned with the plane where the object of interest could move. Let's say if now the object is on the ground, then the plane where the object could move should be this plane. So you should probably keep your x-axis on this plane over here. But what if today you have a situation of an inclined plane, then your block is resting on the plane, then the plane where the object could move should be on this inclined plane, right? So you should expect you should have one of the axes over here, and that is where we usually put our x-axis. And let's say today you have an object hanging, you have a rope hanging an object being hanged like this, then you should expect the thing to be able to move in this direction, up down direction, right? So you should expect you have at least one axis on the plane where the object could move. It doesn't mean it will really move, but what kind of plane is it possible for the object to move? So you should keep one of the axes in there. And of course, you know, x and y should be in perpendicular, they should be perpendicular to each other. So once you determine one of the axes, you will know the other axis should be perpendicular to that axis. Okay, so it's something that you pick up through many practices. Okay, so once you have your object of interest determined, then you have your axis oriented, then now you ask yourself these 5 questions. So these are the 5 questions that you ask yourself to determine what are the forces that are acting on the object of interest. Again, I always highlight the word on because we don't care whether the object is pushing other things or not. We don't care whether the object is pulling other things or not. We only care about what the object is experiencing. Okay, so these 5 questions are related to the previous video on the 5 types of forces that we observe in macroscopic situation. So if you're not sure what are the 5 types of forces, please review the previous video, but these are the 5 questions. So the first thing is, does the object of interest has mass or not? Okay, and is the earth beneath it? You might think it's an obvious answer. Of course, an object has mass, since when an object does not have mass? Well, in physics, yes, it's possible to be massless. Okay, so you have to ask yourself this question always, whether it has mass. If it has mass, is the earth under the object? If yes, then the weight is there, then it's pointing downwards. If the earth is not beneath you, then your weight might be pointing other direction. Okay, next question is there any ropes or cables or strings attached to the object of interest? If it's attached, then you should expect there's tension. Okay, because you attach ropes, strings, cables because you want to pull using the ropes, right? So you should expect you have tension. Next question, are there any forces that are being applied and mentioned explicitly in the question? Okay, you might see a diagram, you see a person pushing, then that one is external force. Or in the question they mentioned, this object is being pushed with a force of 200 Newton, explicitly mentioned. So those forces are called external force. Okay, next, is there any contact with any other surfaces or object? Well, if it's in contact with a floor, if it's in contact with a wall, or if it's in contact with another block, then those are in contact. If you have in contact, for each contact, you need to have one normal force. If you're in contact with 3 different surfaces, then you have 3 normal forces. Okay, so it can get quite complicated at certain times. Okay, last one, is there any rough surface? If there's rough surface, it's most probably that there's frictional forces. So whether it's static friction or kinetic friction, you have to see whether the object is sliding across the surface or not. If it's not sliding across the surface, then it's static friction. If it's sliding across the surface, then it's kinetic friction. Okay, so these are the 5 questions that you should ask. So in the next video, we will show a few examples of how we draw the free body diagram.